Hi everyone. So this is group 48 and I'm Karunj Irene with my group mate.
I'm Dr. Hilary.
Mpiro Adri.
So we are going to take you through our project, and our project's name is a colorimetric machine learning architecture for non-invasive anemia detection through conjunctival image analysis. So our next slide has the contents of the presentation, where we have the introduction, the problem statement, the methodology, the dataset description, the results, the conclusions, the anticipated limitations, the related work, and the references.
So here I'll take you through about the background and introduction of the project you're working on. So anemia basically is, first of all, it's a common health condition faced by many people in the world, and it's caused by low hemoglobin levels in blood. As a result, it reduces the body's ability to transport oxygen. Yeah, and so anemia has been diagnosed traditionally in many hospitals through taking blood samples, but however, we are coming up with a new method which is non-invasive. By non-invasive, I mean don't have to use the body, in this case, injecting the body. We shall instead use external features. In this case, the eye images, as you can see in the image below, the conjunctival region at the bottom that is highlighted. That's what shall be using. So these are problem statements. First of all, you had to talk about the domain application problem. The domain basically a range of people, like population base. Yes, as earlier said, anemia affects millions, especially in areas lacking medical labs, becomes a very critical challenge as equipments to draw blood are few, and so we need to come up with a new best method to solve that, and which leads us to our computational problem that involves developing a reliable computer vision system to detect anemia, sorry, that will involve taking a picture of the eye conjunctiva and analyzing it. Yes.
Let me take you through the methodologies and the system architecture. One where we are going to use image acquisitions. That's where we're going to be using our smartphones and cameras. We pre-process the image. That means enhancing the image quality. We do feature extractions. That means we extract the color white channels and the textures and the rest. And then we do model training. That is now our machine language process now. And then we have our result output. That means displaying the risk categories. That means, is it normal, mild, or severe anemia? And then we go to the dataset description and exploratory data analysis. That is one. Dataset descriptions. That means we have around 218 data sets, and then we have they're divided into two. That is Italy and for India. For Italy, that's 123 patients, and then for India, images about 95. And then we have each image has the variables, the hemoglobin level, the gender, and the segmented conjunctive region. And then we have the intended data sets. The data set is intended for anemia detection, image segmentation research, and then we have the objective of the EDA. That means to understand the demographic distribution, the analysis of the hemoglobin distribution or anemia pairs. And then we have also exploring the relationship between the hemoglobin and the age, stroke gender. And then we have color, and then segmentation, consistency. Then we have, next slide, please. And then here we have the output results and discussions. That means we have here our variables and then the descriptions, and then we do some data cleaning. That means, like, for data cleaning, we find the missing values where the patients 90, that is in Italy, 93 patients have missing hemoglobin values. And then if we come back here, we have our variables where we have the number, the patient ID, hemoglobin level, we have the age, gender, country, and then the color features, the lab features also. Then next slide.
So after analyzing and cleaning our data set, we had to do further EDA by drawing graphs to show different variations of the data and how it behaves with each other. So first we did the age distribution. As you can see on the graphs aside, we have age distribution based on depending on anemia. So you can see these are different graphs you can see here. gender distribution, age distribution, anemia, yes. So we further continue to visualize the anemia aspect further. As you can see here, anemia is categorized in terms of gender, in terms of number of people with it, in terms of age, in terms of country. Yes. So further, the same thing, we came up with a hemoglobin distribution curve, as you can see here. Hemoglobin distribution curve, again, is hemoglobin. So the geometric proportion, again, is the hemoglobin distribution. Then on our left-hand side, we categorize hemoglobin distribution by gender of a person and the country. In this case, is India and Italy.
Okay, here we have some expected results and discussions. That means the image-based EDA, and then we have the extracted image samples. That means we have here some sample eyes. That means of the one that somebody is supposed to capture, so that we can be able to detect anemia. And then next, and then here we have the histogram showing the colors, color what? Pixel intensity or are distributed across all images, helping you to see the color are more common and how they vary. And then here we have the distribution, the image brightness distribution. That means we're plotting the brightness of an image, how it is distributed generally, the brightness levels. Next slide.
So here we are demonstrating our developed product, what our developed final product will look like. So the first stage, in case this time you have a mobile app, the first step it will have be capturing an image whenever an health worker takes an image of a person using a phone using the app, takes a picture, a photo of the patient's inner eyelid, the conjunctiva. Then this image goes through another process of automatic extraction, the features extraction. So the system takes and crops the conjunctival region automatically and removes the relevant parts. In this case, we want to focus on the conjunctival region alone. Then the next part will be colorimetric analysis. The image will be cropped and converted from RGB to lab color space. And in lab color space, there are chromatic vectors which will be extracted to determine the conditions that we shall feed into the system to base whether someone has anemia or not. So now then the fourth will be the machine learning prediction. We've come up with a model. One of the models is SVM and others random forest based models. So these models now that we would have trained will now go in place to predict whether someone is anemic or non-anemic. Then in the end, after discovering, we shall display the results and say this person is anemic, and also we shall provide further guidance step in case the person is anemic, do this, and if not, yeah, like that. Okay, as you can see, also the confidence scores will be given 80% sure. Yes.
So our conclusions and limitations. So this study shows that the conjunctiva eye images can be used with machine learning techniques to help detect anemia non-invasively by analyzing color features related to hemoglobin levels. The model can classify patients as anemic or non-anemic. This approach has potential to support faster, low-cost anemia screening, especially in areas with limited access to laboratory testing. Then the limitations we have small data set size. The data set contains images from only 218 patients, which may limit the model's ability to generalize to larger populations. And then our suggestion is future studies should include more patients from multiple regions to improve model reliability. In the next steps, we have real-world testing. The model should be tested in real clinical environments using images captured with different smartphones and lighting conditions. Then to develop automated segmentation, future work should focus on building automatic algorithms to detect and segment conjunctiva regions without manual annotation. Then these are some of the related work, like the people who have the work related to ours, the project that we are working on. And then these are the references that we were using as to do our. Thank you very much.
Okay.